students, in the last class we have studied valence bond theory, right? So valence bond theory is based on the orbital overlap concept and hybridization. Orbital overlapping means intermixing of the atomic orbitals takes place. So that is improved by the hybridization. In the hybridization, overlapping, that is intermixing of the orbital takes place, forming the new set of the orbitals which are equivalent in energy and shape. This new set which are formed, that is called the hybrid orbitals. Hybrid orbitals are involved in the bond formation, means they are more effective in the bond formation. So this hybridization, different types also we have studied: sp hybridization, sp2 hybridization, sp3, that is involving s and p orbitals. If d orbitals involved, then d sp2, sp3 d2, sp3 d, different types we have studied. Right? So next is molecular orbital theory, that is latest concept. Before going that, the small concept is there, that is hydrogen bonding at the end of this chapter. I will finish that one first. Okay? Hydrogen bonding. So if hydrogen is bonded to strong electronegative elements, and strong electronegative elements, three are there, that is fluorine, oxygen and nitrogen. When hydrogen is bonded to these fluorine, oxygen or nitrogen, it will, what happens? For example, I will take H, X. X is a strong electronegative element. Okay, X is electronegative element. So here, shared pair of electrons. So this is sharing a pair of electrons between H and X. The shared pair of electron is more towards the X. Shared pair of electron is displaced, is more towards the electron, is displaced more towards X. Yes, as it is highly electronegative in nature, it will attract shared pair of electron towards itself. That gives fractional negative charge on the X and fractional positive charge on the hydrogen. Okay, fractional negative charge on X, that is highly electronegative element, and fractional positive charge and hydrogen. So it leads to the development of polarity, right? There is existence of polarity in the bond. So this partially positively charged hydrogen, it has the tendency to attract the highly electronegative element of the other molecule. For example, here HX is there. Okay, so in this HX molecule, X minus is partially negatively charged and H is partially positively charged. Okay, the hydrogen of the another molecule, since it has attained a partially positive charge, it has tendency to attract the highly electronegative element of the another molecule. It has tendency to bind or tendency to attract the partially negatively charged element, that is highly electronegative element of the another molecule. Okay, so what happens here? That bond, this bond is hydrogen bond. So this bond is called as the hydrogen bond. Okay, this is the cause of the hydrogen bond. When hydrogen is bonded to highly electronegative atoms, fluorine, oxygen, nitrogen. Okay, in this case, because these three are highly electronegative atoms. For example, here X can be fluorine, oxygen or nitrogen. The shared pair of electron is displaced more towards the X because it is highly electronegative, so it is displaced more towards the X. That gives a partial negative charge or fractional negative charge on the X. That is called, this symbol is delta. Delta symbolizes fractional or partial. So delta negative on X, and since hydrogen, it has given its electrons moved towards the electronegative atom, it attains partial or fractional positive charge. So now polarity is developed in the molecule. So this partially positively charged hydrogen, it can bind or it will attract towards the partially negatively charged highly electronegative atom of the another molecule. That force, attractive force, so that attractive force which binds hydrogen atom to highly electronegative element of another molecule is called as hydrogen bond. Is called as hydrogen bond. Okay, attractive force which binds hydrogen atom of one molecule, hydrogen atom, to highly electronegative element of the another molecule. Hydrogen atom of one molecule, okay? Hydrogen atom of one molecule. Means hydrogen atom of this molecule is attracted towards the highly electronegative element of the another molecule. So in this one, this dashed line, hydrogen bond is represented in dashed line, whereas this solid line, this is the covalent bond. Okay, this is the covalent bond. The solid line is covalent bond and dashed line is hydrogen bond. Okay, that is the definition and the cause of the hydrogen bond. For example, HF, if we see HF molecules. This is one HF molecule. This is another HF molecule. In the same molecule, H and F are bonded by the covalent bond. Between two HF molecules, this H will bind to the fluorine of the another molecule by the hydrogen bond. Why? Because fluorine is partially negatively charged and hydrogen is partially positively charged. There will be attractive force will be there. Okay. So this hydrogen, now it acts as a bridge between the two highly electronegative atoms, right? So hydrogen acts as a bridge by forming hydrogen bond with the one of the electronegative element of the another molecule and forms the covalent bond within the same molecule, right? Here covalent bond with the same molecule, with the another molecule hydrogen bond. Both are electronegative atoms. This is similar compounds, similar molecules. Between alcohol and water, if you of hydrogen bond, that is strength of the hydrogen bond. The magnitude of hydrogen bond depends upon the state. Magnitude of hydrogen bond depends upon state of the molecule. Depends upon the state of the molecule. 3 states: solid state, liquid state and gaseous state. So hydrogen bond is maximum in solid state and minimum in gaseous state. Okay? Maximum in solid state. Solid state, the molecules are closely packed with each other, right? Whereas in the gaseous state, they are far away from each other. Therefore, the hydrogen bond is strong in solid state and least in the gaseous state. So this remember for competitive exams. Then hydrogen bond, it will influence, hydrogen bond will influence the physical properties, physical and chemical properties of the molecule. Properties of the molecule. Hydrogen bond, it gives an additional force, right? It is an attractive force, means it gives an extra force for the bond. Covalent bond is there, ionic bond, different bonds are there, right? Similarly, if hydrogen bond is there, covalent molecule with the hydrogen bond, a little extra energy is required to break the 2 bonds are there, little extra energy is required. Therefore, it will influence the physical and the chemical properties. Next is types of the hydrogen bond. There are 2 types of hydrogen bond. Two types of hydrogen bond. One is intermolecular. Intermolecular hydrogen bond. And the second one is intramolecular. Intramolecular hydrogen bond. By the name itself you can understand it. Intermolecular, between the molecules. Between molecules. It can be of same or different compounds. Intramolecular. Intra means within the molecule. Okay. Inter means hydrogen bond present between the 2 different molecules of same or different compounds. Hydrogen bond present in different molecules, between different molecules, not in, between different molecules of same or different compound. Different compounds. Example, hydrogen bond in HF molecules, alcohol, water, etc. Means between the 2 different HF molecule it is present, or between 2 different alcohol molecules, ethanol, C2H5OH molecules, or between 2 different water molecules, right? Or between the alcohol and the water molecules. Therefore, it is given different molecules of same or different compound. Same compound means it will be HF, alcohol, water. Different compounds means between alcohol and water. Okay, so that is the intermolecular hydrogen bonding. Then intramolecular hydrogen bonding. Intramolecular, if the hydrogen is present between 2 highly electronegative element So this hydrogen bond is present within the molecule. When the intramolecular hydrogen bond will form, if hydrogen bond is present between two different highly electronegative elements. Okay, so that we'll see. Example is orthonitrophenol. Intramolecular example is orthonitrophenol. Okay, what means that is orthonitrophenol. So phenol, you know, benzene ring, okay, with OH. This is the phenol. Okay, nitro group means NO2 group. So this is orthonitrophenol. Okay, 1 and 2 position functional groups are present. 2 more are there, meta and para. This is meta-nitrophenol. Okay, and the first and the third carbon. Okay, first and the third carbon. This is meta, 1 and 3 positions, functional groups. One more is there, that is para. Para, 1 and 4 position, exactly opposite. This is NO2, okay, and this side exactly opposite OH. This is called para-nitrophenol. Okay, para-nitrophenol is 1 and 4 position. First carbon, second carbon, 3, 4th carbon. Here first, second, 3. Whereas here ortho 1 and 2, second carbon. So now see, intramolecular hydrogen bond is present in the orthonitrophenol. Intramolecular hydrogen bond. Okay, so in this diagram, I will rewrite it to show the hydrogen bond. Okay, this NO2 N double bond O and this bond O, this is coordinate bond. Okay, so simple coordinate bond is simple like this. This is NO2 structure and this O H is like this. Okay. Now this particular hydrogen is placed in between two highly electronegative elements. So there is an attractive force will be there. So this bond is called as the hydrogen bond. Okay. See, meta-nitrophenol, M-nitrophenol, 1, 3 positions. It is far away, right? They are not near to each other. Para-nitrophenol, it is exact opposite is there. Here also intramolecular is not possible. Orthonitrophenol, functional groups are present adjacent carbon. They are present at the adjacent carbon. If you elaborate, if you write the structure, it is like this: NO2, N double bond O and single bond O. Okay, and this bond is coordinate bond, means nitrogen will give a pair of electron. It is shared by the N and O. And this OH here, OH, this is the covalent bond. Now this H is between two oxygen which are highly electronegative. So there is an attractive force. So this bond is called as hydrogen bond. Okay, within the molecule. If hydrogen is present in between two highly electronegative element or atom, then intramolecular hydrogen bond is formed. That is orthonitrophenol. Okay, One question is given in printed notes. Which has higher boiling point? Which has higher boiling point? Orthonitrophenol or paranitrophenol? Orthonitrophenol or paranitrophenol is the question. Answer for this one is paranitrophenol. Paranitrophenol. Here paranitrophenol you can write as P only. P for paranitrophenol. The reason boiling point is highest in paranitrophenol because here intermolecular hydrogen bonding will be present. Because of the intermolecular hydrogen bond. In the paranitrophenol, intermolecular. See, NO2 is here, OH is here. Are far away from each other. 1 and 4 position. So, within the molecule, hydrogen bond will not form. But between two different paranitrophenol molecule, hydrogen bond will be formed, right? If we form two different molecules, then it is called as intermolecular. Because of the intermolecular hydrogen bond, association of the molecule takes place. Association of molecule takes place. Okay, means different nitrophenol molecule is there, paranitrophenol molecules is there. Between them, if binding force is there, means it forms a network-like structure. That is, association of the molecules takes place. It requires an extra energy to break the bond. Whereas orthonitrophenol, within the molecule, hydrogen bond will form. Between two different orthonitrophenol, hydrogen bond will not be formed. It remains single molecule as it is. So it can be easily, bond can be easily breaks there. Okay. Therefore, paranitrophenol has higher boiling point. Okay. Hope you understood this one. So here hydrogen bond definition will be asked and types of hydrogen bond. Okay. And their definition can be asked. Or this question can be asked. So next is the latest concept. It is the latest theory to explain chemical bonding and molecular structure. It is molecular orbital theory. Okay, molecular orbital theory. Shortly called as MOT. MOT theory. So as in the name it is there, molecular orbital will be formed. Okay. Salient features. There are 7 salient features. Salient features means the specific characteristics of the molecular orbital theory. First one, okay. The electrons in a molecule, are present in various molecular orbitals. As the electrons in atoms, in a atom are present in various atomic orbitals. The first salient feature, the electrons in a molecule, they are present in various molecular orbitals. Like the electrons in the atoms are present in various atomic orbitals. So in structure of atom lesson we have studied electrons will be in the atomic orbitals, or that is subshells, right? That is atomic orbitals in the atoms. Similarly in molecules, orbitals are called as molecular orbitals. Okay, molecular orbital. This is the first picture. Second one, the atomic orbitals. Atomic orbitals of comparable energy, and proper symmetry, combine to form molecular orbitals. So these molecular orbitals are formed by the combination of the atomic orbitals. The combination of atomic orbitals takes place if only the atomic orbitals of comparable energy and proper symmetry. Okay? Energy should be comparable. It can be same or nearly same. That is comparable energy. And symmetry of the atomic orbitals which are combining, it should be proper. Means it should have same symmetry. Okay. Next one. These are the two. Next, third one. Electron in an atomic orbital. The electron in an atomic orbital is influenced by one nucleus. The electron in molecular orbital. The electron in molecular orbital are influenced by two or more nuclei, depending upon the number of atoms, present in molecule. Therefore, atomic orbitals are monocentric. And molecular orbitals are polycentric. Okay. In the atomic orbital, atom means it's a single nucleus will be there. So therefore, atomic orbital will be influenced by one nucleus. The electron in the atomic orbital will be influenced by one nucleus. But if you take the molecule, if combination of two molecules, it's a diatomic molecule, two nuclei will be there. If combination of three different molecules, then it is triatomic molecule. Then three nuclei will be there. Similarly, tetraatomic. So depending upon the number of atoms present in the molecule, there will be number of nuclei, two or more nuclei will be there. So electron in the molecular orbital, it will influence by two or more nuclei. That depends upon the number of the atoms present in the molecule. Therefore, atomic orbital is called as monocentric, means only one nucleus, whereas molecular orbitals are called as polycentric. polycentric. Poly means many. Okay, so it can be 2 or more nuclei, right? So it is polycentric. Okay, electron in the atomic orbital is influenced by one nucleus, whereas electron in the molecular orbital is influenced by 2 or more nuclei. That depends upon the number of the atoms present in the molecule. Because of that reason, atomic orbital is monocentric, molecular orbital is polycentric. Okay, this is the third salient feature. Next, fourth one. The number of molecular orbital formed. The number of molecular orbitals formed is equal to the number of atomic orbitals combining. Okay, if 2 atomic orbitals combine, then 2 molecular orbitals are formed. Then 2 molecular orbitals are formed. Okay. One is bonding molecular orbital. And the other one is anti-bonding molecular orbital. Okay, so the number of molecular orbitals formed is equal to number of atomic orbitals combined. If 2 atomic orbitals combine, 2 molecular orbitals will be formed. Okay. If 8 atomic orbitals are combined, 8 molecular orbitals will be formed. Okay. 2 atomic orbitals means 1 atomic orbital of the one atom, the other atomic orbital of the other atom. Okay, the atomic orbitals of 2 atoms, one from each. It combines, it forms 2 molecular orbitals. In that 2 molecular orbital, the one molecular orbital is called as bonding molecular orbital. That is the name of the molecular orbital, bonding. The other one is called as the anti-bonding molecular orbitals. Okay. Next one. Fifth one. The bonding molecular orbital. The bonding molecular orbital has lower energy. Than the corresponding anti-bonding molecular orbital. Anti-bonding molecular orbital. Okay, so 1 point is it, right? Bonding molecular orbital has lower energy, hence greater stability. Hence, before this, okay, hence greater stability. The bond energy, hence greater stability than the corresponding antibonding molecular orbital. For example, 1s. 1s atomic orbital will combine and 1s atomic orbital of the other atom. It combines form the two molecular orbital, that is bonding molecular orbital and antibonding. The bonding molecular orbital of the S type is named as sigma. Sigma molecular orbital here. Okay, sigma bonding molecular orbital, that is sigma 1s and sigma star 1s. This is antibonding. This is bonding molecular orbital. And this is anti-bonding molecular orbital. See, two atomic orbital is combining, so two molecular orbital is formed. One is bonding molecular orbital named as sigma 1s. Anti-bonding molecular orbital of this is named as sigma star 1s. Here, bonding molecular orbital has lower energy, hence greater stability than the corresponding antibonding molecular orbital. When I say sigma 1s, you have to compare its energy with its corresponding antibonding molecular orbital, sigma star 1s. Okay. Next one. Next two are there. Next two salient features. There is sixth one now. Just as the electron probability distribution, in an atom is given by atomic orbital the electron probability distribution in a molecule around a group of nuclei, in the molecule is given by molecular orbitals. What is atomic orbitals? Atomic orbitals are it gives electron probability distribution. The probable distribution of the electrons around the nucleus in the atom. Right? Similarly, the molecular orbital means it gives the probable distribution of the electrons around the group of nuclei in the molecule. Okay? The difference is only one difference. That is, atomic orbital is present in atoms, it will be one nucleus, whereas molecular orbital is present in molecules, it will be having two or more nuclei. Okay? This last one. Okay. That is the molecular orbitals. Like atomic orbitals are filled in accordance with Aufbau principle, obeying Hund's rule. Hund's rule or Hund's rule. Pronunciation is up to you. Okay. So the last one salient feature, that is atomic orbitals, how it is filled by the with the Aufbau principle, obeying Pauli's exclusion principle and Hund's rule, right? Similarly, filling of the molecular orbitals is similar to that of the atomic orbitals. Aufbau principle, that is filling of the molecular orbitals with the increasing order of their energy. Lower energy molecular orbitals are filled first. So with the increasing order of the energy of the orbital, filling takes place. Pauli's exclusion principle means it is a molecular orbital, it can have maximum 2 electrons with the opposite spin. So one molecular orbital, it can have maximum 2 electrons. With the opposite spin it should be there. Then Hund's rule. Hund's rule, that is pairing of electron in degenerate orbitals takes place only if they are singly occupied. Degenerate orbitals means orbitals having same energy. So molecular orbitals which are having same energy, first they should be singly occupied, then doubly occupied. Means filling of the second electron takes place in each orbital. First they should be singly occupied. Okay. So pairing of the electron in degenerate orbitals takes only after they are singly occupied. Okay. So that is the salient features of the molecular orbital Tn. Okay. I will repeat this one. Look at the points, 7 points what you have written. The first one, electrons in the molecule, it is present in molecular orbital, like the electron in the atoms are present in various atomic orbitals. Okay. Next one, atomic orbital of comparable energy and proper symmetry combine to form the molecular orbitals. The number of molecular orbitals formed is equal to the number of atomic orbitals combined. These atomic orbitals, if 2 atomic orbitals combine, then 2 molecular orbitals is formed. One molecular orbital is called as bonding molecular orbital. The other one is called as anti-bonding molecular orbitals. Okay. Next is, in the atom, electron, it will be influenced, present in the atomic orbital, it will be influenced by one nucleus. Therefore, atomic orbital is monocentric. Whereas in the molecule, electrons in the molecular orbital will be influenced by 2 or more nuclei. That depends upon number of the atoms present in the molecule. Therefore, molecular orbitals are polycentric. Okay. Next, bonding molecular orbital, it has lower energy, so its stability is more. So molecule, if it has lower energy, it is more stabilized, right? Similarly, bonding molecular orbital is having lower energy, so it has more stability than the corresponding anti-bonding molecular orbital. Meaning, we are comparing the energy of bonding and anti-bonding molecular orbital of same type. Okay. Next one, the electron probability distribution around the atomic orbital, right? So electron probability distribution around the nucleus in the atom is given by atomic orbital. Similarly, in the molecule, the electron distribution around the group of nuclei in the molecule is given by the molecular orbital. Next is filling. Like in the atomic orbital, how it is filled, similar way molecular orbitals are filled, that is in accordance with the Aufbau principle, obeying Pauli's exclusion principle and Hund's rule. Okay. These are the 7 salient features. Remember any 4. To understand the concept, all the 7 you should study. Okay. Next we'll see conditions for for the combination of atomic orbitals. Conditions for combination of atomic orbitals. Okay. There are three conditions. First one, the combining atomic orbitals must have same or nearly same energy. Same or nearly same energy. Okay. It means 1s. It can combine. 1s combines with 1s orbital. 2s combines with 2s. Similarly, 2p will combine with 2p orbitals. It is 2pz with 2pz, 2px with 2px, 2py with 2pz. Sorry, 2py. Okay. This is in the homonuclear molecules. In homonuclear molecules means similar atoms. Similar atoms. So combining atoms are having same energy. 1s means 2s. 2pz means it is having same energy. In heteronuclear molecule, heteronuclear means different atoms. Different atoms. In the heteronuclear, nearly same energy, atomic orbitals of nearly same energy means 2s, it can combine, 2s can combine with 2pz. 2pz. Okay? 2s can combine with the 2p orbitals. That is where in the heteronuclear, but in the homonuclear molecule, same energy should be there. Combining atomic orbitals should have same energy. Then next one, the second condition, the combining atomic orbitals, the combining atomic orbitals must have same symmetry, about the molecular axis. About the molecular axis. The combining atomic orbitals must have same symmetry about the molecular axis. By convention, z-axis is the molecular axis. Okay, molecular axis or internuclear axis, or bond axis are the same. Okay, molecular axis, internuclear axis, and bond axis. These are one and the same. So by convention, z-axis is the internuclear axis or molecular axis or bond axis. So now combining atomic orbitals must have same symmetry, meaning 2s. If 2s and 2s combined, it is having same symmetry. 2s and 2p if you consider. 2s is along the internuclear axis, it is here, right? So this is the nucleus. So along the internuclear axis. 2pz also if you take 2pz axis also along the internuclear axis, whereas 2px and 2py if you take, px and py if you take, these are not along the internuclear They are perpendicular to the internuclear axis. Therefore, 2s with 2pz is possible. But 2s with 2px or 2py is not possible. Okay. In the heteronuclear molecules, so like this combination will take place. In homonuclear, similar type should be there. Okay. So 2s with 2pz is possible, whereas 2s with 2px or 2py is not possible. Energy is comparable. So according to first condition, 2s and 2p can combine. But if you go in types in that 2p orbitals, 2s with 2pz is only possible because both are having symmetry about the molecular axis. In 2px or 2py, the symmetry is perpendicular to the molecular axis. Because of that reason, 2s with 2pz is possible, but 2s with 2px or 2py, that is not possible. This third condition, the overlapping, it should occur to a maximum extent. To a maximum extent. Okay. If 2s and 2s they are combining, that is overlapping of two 2s orbitals, the overlapping should be at maximum extent because then stronger bond forms. Bond forms will be stronger if extent of overlapping is maximum. So these are three conditions. First one, the combining atomic orbitals must have same or nearly same energy. Second condition, the combining atomic orbitals must have same symmetry about the molecular axis, that is about the z axis. Then the overlapping, it should occur to a maximum extent or to a greater extent so that strong bond will form. Okay. So here bonding molecular orbital it has lower energy, whereas antibonding molecular orbital has more energy. Antibonding molecular orbital has more energy. The reason is in the electrons in the molecular orbital there will be attractive force between electron and nucleus. Okay, so that will stabilize the molecule. So bonding molecular orbital has lower energy, whereas in the anti-bonding molecular orbital, the repulsion between the electrons, stable. Okay. So when we combine, if you look at the diagram, energy level diagram, so next class I will be doing. If you combine two atomic orbitals, bonding molecular orbital energy
Hello everyone. So last class we discussed about general equation of line. That is ax plus by plus c is equal to 0, where a, b, c are constants and a and b should not equal to 0 simultaneously. So last class we discussed about general equation of line. And also we considered this general equation of line in terms of slope-intercept form, intercept form and normal form. I mean, if the equation is given in general form, you should know how to find the equation in intercept, slope-intercept form and normal form. See, if general equation is ax plus by plus c is equal to 0, then slope-intercept form will be y is equal to minus a by b, okay, and p of a square plus b square. This is the form. Then this, if line is x plus by plus c is equal to 0, if line is given, and point as x1 y1 is given, then distance between line and point we taken as small d is equal to modulus of a x1 plus b by 1 plus c divided by root of a square plus b square. This is the formula to find distance between a point and a line. These things we discussed in the last class. Now today we will discuss one more concept, that is distance between two parallel lines. Okay? Next we will see distance between two parallel lines. See, I have taken two parallel lines in plane L1 and L2, and we know about one condition about the parallel lines, that their slopes are same, isn't it? So can I take, let the two parallel lines L1 and L2 with equations y is equal to mx plus c1 and y is equal to mx plus c2. Since slopes are same, can I take the equations as y is equal to mx plus c1 and y is equal to mx plus c2? Instead of taking m1 and m2 separately, since they are one and the same, slopes are one and the same, since they are parallel lines, can I take y is equal to mx plus c1 and y is equal to mx plus c2? Of course, here I have not taken in general equation form, I have taken in slope intercept form. It's fine. Later we will see the same thing in general equation form. Okay? So I have taken the equations in slope intercept form. See, the slopes are same because they are parallel lines. Now I have to find distance between them. We know how to find distance between point and a line. Let me take at least a point here. I mean, see, line L1 is passing through x-axis, isn't it? Can you see here? Let me give the name this as A. Okay, this point. Okay, this is not a line, students. I am writing the point A here. Is it fine? This is not a straight line. This arrow mark. I am writing point A here. Okay. So when it passes through, line L1 passes through x-axis. See what happens. Let me write it here. When the line L1 passes through x-axis, of course here y will be 0, isn't it? Here y will be 0. What is the equation you have taken for L1? See, y is equal to mx plus c1. If y is equal to 0, it happens y is equal to minus c1. So x will be minus c1 by m. Am I right? See, you can't see this. Y is equal to mx plus c1. This is equation of first straight line. When you substitute y is equal to 0 here, it will be mx is equal to minus c1. So x is equal to minus c1 by m. Am I right? When line L1 passes through x-axis, here y will be 0 and x will be this. So can I take the coordinate of A as, let me write coordinate of A here, A of minus c1 by m, comma 0. Can I take this point A as its coordinate minus c1 by m, comma 0? I have written the reason here, just go through this. Since L1 passes through x-axis, y will be 0 there. Substitute y is equal to 0 in that particular equation. So you will get x value. So the coordinates are minus c1 comma m, minus c1 divided by m comma 0. So this is the point. So can I take this distance as a parallel distance now? It is a perpendicular distance from line L1 and L2, isn't it? From line L1 to L2. The point is known and this is the straight line. What is the equation? Y is equal to mx plus c2. What about this equation? Y is equal to mx plus c1, isn't it? I have written this. So, since L1 passes through x-axis, then coordinate of A is minus c1 by m comma 0. Is it fine? Minus c1 by m comma 0. Now, distance between line L2 from point A is given by, see, I am finding distance between point A from the line L2. I mean, if you find distance between point A and L2 is nothing but finding distance between two parallel lines. So I have taken one point and L2. Did you get now why I considered one of the point on L1 here? So let me use the formula now. You know what is distance between, let me erase this now. You know what is distance between point and the line, isn't it? So if the equation is in the form of x plus by plus c is equal to 0 and the quantity is x1, y1, then distance between them is what? Mod of x1 plus by1 plus c divided by root of a square plus b square. This is the formula, isn't it? Where the equation and points are given. But here the equation is in which form? Slope-intercept form. And the point is what here? Point is minus c1 by m comma 0. First you have to convert this equation in slope-intercept form, or just convert this into general equation form. Then it will be easy for you to substitute here, isn't it? See what we have. Y is equal to mx plus c2. This is what equation of L2, isn't it? I need to convert this into general equation form. Then it will be easy for you to substitute A, B, C value, isn't it? So y is equal to mx plus c2. See, y is equal to mx plus c2. I am trying to write this in ax plus by plus c is equal to 0 form. So can I write mx minus y plus c2 is equal to 0? You just compare this to this and see the value of a. Is a m, because the coefficient of x is a here, the coefficient of x is m, and the coefficient of y is b here and here minus 1. So b is minus 1 and coefficient and c constant is c2 here, isn't it? And the point we already know, the point is what? A of, don't get confused between this a and this, okay? This says the coefficient of x and this says the coordinate. This is the point what we have taken in L1. So the point is known. Point is what? I mean x1 comma y1 is what? Minus c1 by m comma 0, isn't it? See, you have a, b, c value and also x1, y1. Now can you find distance between a point and a line from this formula? I am writing it here. So d is equal to, d is, I am finding distance between point and a line. It is nothing but distance between two parallel lines here, isn't it? So d is modulus of ax1. What is a here? M. x1 is what? Minus c1 by m. Am I right? Plus b is what? Minus 1. Y is what? 0. y1 is 0. And plus c is c2. Divided by root of a square plus b square, so m square plus minus 1 whole square is 1 square, isn't it? See, you can write it somewhere, okay? Did you get how I consider? This is slope intercept form. Let me convert it to general equation form. How we convert? Very simple, just make the equation in the way it should show like ax plus by plus c is equal to 0. And the point is x1 y1 is minus c1 divided by m comma 0. And I substituted everything here. Is it fine? Let me continue here. So d is equal to, this actually what, students? Let me write. So distance between a point or I can say distance between two parallel lines directly. Two parallel lines, isn't it? Because here d is what? Distance between this point and this line is nothing but actually what? Perpendicular distance is nothing but here distance between parallel lines. So two parallel lines is equal to, let me simplify this, n gets cancelled. So is it minus c1 plus c2 divided by root of n square plus 1. So is it modulus of c2 minus c1 divided by root of n square plus 1. So this is distance between two lines. And here we can use this formula when the equations are given in slope intercept form. Imagine the equations of these two straight lines are given in general equation form. We'll see how to find. Okay. So this is the formula, distance between two parallel lines. All the derivations are important, dear students. And if you learn the derivations properly, then the problem will be more easier. Okay. So this is the distance between two parallel lines. Did you get? I mean, distance between point and the line is nothing but your distance between two parallel lines. So we have taken this is equal to. So we can use this formula when the lines are given in slope intercept form. Imagine the lines, if lines are given as a1x plus, we'll take the two lines as ax plus by plus c1 is equal to 0 and ax plus by plus c2 is equal to 0. Then we'll see distance between them if it is given in this form. We just observe. I have taken ax plus by common in both the equations. Ax plus by. Because when it was in slope intercept form, you consider M for both, isn't it? Because they are parallel lines, slopes are same. That's why the value of A and B also same. Okay, A and B. So I have taken for the two parallel lines as what? Ax plus by plus c1, Ax plus by plus c2. Only this values will be different. See, even in the formula we just observe, slope is same, M, for both the equation. The only difference is c1 and c2, isn't it? So this is small c1, c2, this is capital. Okay, you should know the difference between this. This is given in what? Slope intercept form. Now it is given in general equation form. So we'll see the formula. B is modulus of C2 minus C1 divided by root of m square plus 1. In the beginning of the class, in the first thing I have given you, that is y is equal to minus a by b x plus minus c by b, isn't it? So this is what? I mean, you are converting the general equation into slope intercept form. That is y is equal to mx plus c, where m is what? Minus a by b and c is what? Minus c by b, isn't it? Imagine if the equation is given in intercept form, then how will you convert it? Can I substitute c2 as, imagine this is c2, one more equation, a by bx plus minus c1 by b. Okay, minus c1. This is c2 by b and c1 by b. I mean, here it is both are in the form of y is equal to mx plus c. I am just converting it. Okay, in place of m you have minus a by b, and in place of c you have, for the first line, minus c1 by b, for the second line, minus c2 by b, isn't it? So can I substitute c2 as minus c2 by b, minus c1 as minus c1 by b divided by root of m square as what? M square, what is m? Minus a by b, so a by b whole square plus 1. And when you solve this, you just see what you will get. So modulus of c1 minus c2 divided by the root of a square plus b square. So you should know the difference between the formula, okay? So this is the formula, just simplify this. Take s in the numerator, similarly the denominator, in both numerator and denominator b gets cancelled, so this will left. So this is the distance between two parallel lines when the equations are given in general equation form. Okay, so this is distance between two parallel lines when it is given in slope intercept form. This is distance between two parallel lines when it is given in general equation form. So just compare the slope intercept form with this. This is actually what? This is the conversion of general equation into slope intercept form, isn't it? What we studied in the last class. So in place of m you have minus a by b. See, here also minus a by b. And the values of y intercepts will substitute in place of c2 and c1. Substitute m value and will simplify this. This is what you will get for the distance between two parallel lines. And instead of writing for modulus for entire thing, it's enough, isn't it? Because the formula is this straight here. Similarly here, even if you write fine, because it is root, right? In the denominator it is plus root, right? So this is the standard formula to find distance between two parallel lines. Next we'll see problems based on these informations, what you studied in this class and the last class, okay? Next we'll see problems based on this information, what we studied in last class and today's class, that is distance between two parallel lines. Reduce the following equations into slope intercept form and find the slopes and y-intercepts. They have given equations, students. When you see the equations, you can make out it is given in general equation form. So what is the question? Reduce the following equations into slope intercept form and find slopes and y-intercept. Slope intercept form means you have to convert into this form you have to reduce the equation into this form, then easily you can make out its slope, and this is what? Y-intercept. Isn't it? So if you convert the given equation into that form, then it is easy for you to make out which is slope, which is y-intercept. So very simple, we take the first question, students. What is the first question? X plus 7y is equal to 0. I am trying to convert this into slope-intercept form. Even in derivation, you consider what if b not equal to 0, divide the equation by b and all like that, isn't it? It is not necessary. You just try to convert this to this form, okay? See what I will do here. 7y is equal to minus x. Then y is equal to minus 1 by 7x plus 0. See, just I converted in the form of y is equal to mx plus, if you don't have any constant element here, just take it as plus c. Did you observe? 7y is equal to minus x. I just converted. Now, this is what is in slope intercept form, isn't it? And slope is minus 1 by 7. I mean, when you compare this to this, see, y is equal to mx plus c. In place of m, what you have? Minus 1 by m. And y-intercept is what? 0. Y-intercept. I mean, this line is not passing through y-axis. So obviously, this will be what? It may be passing through origin or x-axis, isn't it? So this is what? Slope and y-intercept of this line. Similarly, can you find for second one? Same method. Let me write here the second question. 6x plus 3y minus 5 is equal to 0. Again, let me convert into y is equal to mx plus c form. Which is slope intercept form. So 3y is equal to minus 6x. See, I'm just shifting 6x to RHS. Minus 6x. Similarly, plus 5. So y is equal to minus 6 by 3x plus 5 by 3. See what I did? I divided throughout by 3. To make this as y, I divided throughout by 3. Similarly here, to make this 7y as y, I divided throughout by 7. Similarly here. So y is equal to minus 2x plus 5 by 3. Is it in the form of y is equal to mx plus c now? So this is the equation what we reduced in slope intercept form, and here slope m is minus 2 and c value c is nothing but y-intercept here is what? 5 by 3. Please write down slope is minus 2 and y-intercept is 5 by 3. Similarly, can you find for third one? Let me write the third one here itself. Y is equal to 0. Of course, slope is 0 and y-intercept is also 0. Y is equal to 0 means which represents what? X-axis, isn't it? In x-axis, y is 0. This represents actually x-axis line. So slope is 0 here and y-intercept is also 0. Isn't it? So directly you can write it. Because this is in the form of what? Y is equal to 0x plus 0. This is what in the form of y is equal to mx plus 0, right? So m is 0 and y-intercept is also 0. So that's the answer, isn't it? Read all the three here. See the next step of question, students. Let's see the next step of question. Next step of question. Reduce the following equation into intercept form and find the intercepts on x-axis. You know how the intercept form looks. Is it intercept form? X by a plus y by b is equal to 1, where a and b are x and y intercepts respectively. So the intercepts on axis respectively, isn't it? So we'll see the first question. 3x plus 2y minus 12 is equal to 0. See, you have to convert this into this form. So see, with the numerator, in the numerator, the coefficient of x should be 1. In the numerator, the coefficient of y should be 1, isn't it? So, can I write the same equation as 3x plus 2y is equal to 12 and divide rho by 12. Why I consider divide rho by 12? Because in RHS, while you are converting into intercept form, RHS should be 1. So I am just making this 12 as 1. So divide rho by 12. So what you will get? 3x by 12 plus 2y by 12 is equal to 1. So here x by 4 plus y by 6 is equal to 1. So is it in intercept form? And what is x-intercept here? X-intercept is 4 and y-intercept is 6. Isn't it? So it's very simple. You just convert the given equation into intercept form and write what is x and y intercepts here. Find their intercepts on axis is nothing but what? Finding x and y intercept. We'll see the second one. Similarly, we'll see the second one. This is very simple question, friends. You just convert the general equation into respective form and extract the particular values. That's it. So 4x minus 3y is equal to 6. Here let me convert this as positive 1. So divide rho by 6. So what you will get? 4x by 6 minus 3y by 6 is equal. So here it will be x 2x by 3 minus y by 2 is equal to 1. Still it is not in intercept form. See, can I write this equation as x by 3 by 2 plus y by minus 2 is equal to 1? Now finally, is it in x by a plus y by b is equal to 1? Is it in intercept form, students? And here, let me write it here, x-intercept is what? 3 by 2. Y-intercept is what? Minus 2. Isn't it? Minus 2 actually represents what? This line passing through y-axis in negative side. That's it. So y-intercept is minus 2. It's very simple, isn't it? Similarly, let's see this one. We don't have x here. Still we try to convert into intercept form. So, can I write the same equation as 3y is equal to minus 2? Divide rho by minus 2. So, 3y by minus 2 is equal to 1. Now, is it in the form of y by minus 2 by 3 is equal to 1? Of course, we don't have x here. I mean, there is no x-intercept here. Only y-intercept we have. And y-intercept is what? Minus 2 by 3, isn't it? See, I have written this equation in this form. 3y by minus 2 as y by minus 2 by 3 is equal to 1. Now, what is the conclusion here? Y-intercept is minus 2 by 3. Concluded, students. First, convert this equation in this form. Now, this is an intercept form. Of course, we don't have x here. If you don't have x here, what it represents? There is no x-intercept. I mean, line is not passing through x-axis. So, only conclude y-intercept is minus 2 by 3. Y-intercept is minus 2 by 3. That is, b value is minus 2 by 3. We'll see some more problems on this. Next. So, the next question. The equation of line is given here, that is 3x minus 4y plus 10 is equal to 0. Then find its slope, first one, and find x and y intercepts. Okay, we need to find both x and y intercept here and also slope. First, we'll write the equation 3x minus 4y plus 10 is equal to 0. I mean, when you convert this equation into slope intercept form, then you will get slope and one of the intercept, that is y intercept. But still we need to find x-intercept here, isn't it? But when you convert this equation into intercept form, you will get x and y intercept, but you will not get its slope form. Isn't it? So it's very simple. We'll convert this equation into slope form, first slope intercept form, and we'll extract slope from that. And we'll convert this equation into intercept form and we'll find its intercepts here. Or else, you can use the formula, students. The formula is, see, in the last class, we converted the equation into slope-intercept form and intercept form, isn't it? If you see, the formula was m is equal to minus a by b, and also the y-intercept is minus c by b, and x-intercept is minus c by a. Okay, from using this formula, you can find slope x and y-intercept directly. I mean, when you compare this equation into general equation form,